All right, students, this video is for our first set of notes in regards to identifying functions. So, as we saw in the previous video with the vending machine, a function is just a one-to-one relationship. So a function is a rule that assigns each x, okay, make sure that works, bam. All right, that assigns each x exactly one y. More specifically, it occurs when every x value is associated with exactly one y value. Now, real quick, just to say here, x could be called domain, it could be called independent, or the input, and the y could be called dependent, range, output, and output. But in general, we're just going to say for every x, there's one y. Now, on the side over here, you'll see it says tables and ordered pairs, right there, tables and ordered pairs. When you are using a table and ordered pair to test whether or not it's an ordered represents a function, look to see if each input, see if I can write with my big fingers, if each input or x value has exactly one output or y value. That's all you do with tables and ordered pairs, and that'll make sense below when we get down here, this section down here. That'll make more sense down there, but let's just keep going, chug it along, get these notes filled in, and then we will come back to that idea. With graphs, if a graph represents a function, it should be able to pass a vertical line test, and we talked about that in the video as well. We also talked about how my fingers are super fat, it's like hot dogs, and it's hard writing on this little screen. But anyway, vertical line test. This means that any vertical line drawn on the graph should intersect the graph at exactly one point or position or spot. It should only intersect one time. And again, that'll make more sense when we work on graphs for the graphing section, okay? Last but not least, certainly not least, I wonder if I can just, don't want to do that. It's giving me every option. There we are, black. We'll just stick with black because I want it to stand out. So for our last one, mapping diagrams, for that last one, it says each, and you can probably guess by now, okay, each x value must connect to only one y value. Make sure that there isn't more than one arrow leaving an x value, and that'll make more sense when we get practice down here. So let's go back up to the blue one, okay? So let me switch my colors here. Blue, bam. The blue was for tables and ordered pairs. It says to test whether or not a table or set of ordered pairs represents a function, look to see if each input or x value has exactly one output or y value. So we're looking right here. When x is -2, it goes to 7, correct? Do we see any other -2s for the x values? You'd say no, so that's good. At -2 went to one value. And so the story remains the same with -1. It's dating one person, or it's with one person. 0 is with one person. 1 is with one person. 2 is with one person. None of the x values were repeating. It was all the exact way it should be. It was a healthy function. It was one-to-one relationship. This is a function. So on your paper, you would need to write function. You see how my handwriting looks better when you give me more space? But anyway, and the reason why is that for every x, there's one y. For every x, there's one y. Again, for every x, there's one y. For every independent, there's one dependent. For every domain, there was one range. For every input, there's one output. For every tomato, there's one tomato. Whatever you want to call it. You know what I mean? It's just this idea of a one-to-one relationship. And you're going to hear me reference it as a relationship. Like you heard the term cheating. None of the x values anywhere here were cheating. Now, if I know my kiddos, some of you are worried about this -1 and the y. The definition says for every x, there's one y. It did not say that for every y, there's one x. And we got to make sure we don't try to control the other person, because we can't do that in life, y'all. We can't make them love us. But that's a story for another day. Anyway, so now the ordered pairs, we're going to go look at the ordered pairs example. -2 is dating 1, that's real cute. Is -2 cheating on nobody? Oh my goodness, look at this. Look at this. See that my ex is in this problem, y'all. -2 is dating 1 and -2 is dating 8. Okay, this is not a function relationship. This is like in the video on the vending machine where I pressed one button and I got 2 sodas. -2 cannot be dating 1 and 8 at the same time. That is no bueno. Okay, this leads to a bunch of heartache. So this is not a function. And let me switch my colors. No, that was correct. That was correct, because we're still using blue. So this is not a function. I'm running out of space, but it's not a function, okay? It's not a function. And we know because it doesn't meet the definition. For every x, there wasn't one y. It was 2 y's in this particular example. Now let's look at the green, the graph. Okay, it says if a graph represents a function, it should be able to pass a vertical line test. This means that any vertical line drawn on the graph should intersect the graph at exactly 1 point. Y'all, we have a graph. It hit here 1 time. If I drew it over here, it hit here 1 time. No matter where I draw the line, it hits 1 time. Once again, vertical means up and down. So I draw an up and down line. Where did it hit? Right there. Did it hit anywhere else more than once? No. So it's a vertical line test. It passed it. Congratulations. This is a function. Okay, but give me more writing space. I'm going to do it over here. Oh, ooh, that was ugly. So that is a function. And your reasoning is that for every x, there's one y. Easy enough, right? Now, our last one, the mapping diagram, was in black. Let me see if I can get it. There you go. Yeah, buddy. All right, so for the mapping diagram, it says each x value must connect to only one y value. I think you're getting functions. Make sure that there isn't more than one arrow leaving an x. Uh-oh. Uh-oh.
Good morning, Mavericks. As a reminder, Mav News is meeting in C222. Once again, Mav News is meeting in C222. Thank you.
Goodness, how rude of her to interrupt our video. Anyway, so each x value must connect to only one y value, and there shouldn't be more than one arrow leaving an x value. Here, x, the x, when x is 0, it's dating who? 5. It's dating one person. That's good. That's cute. And who's 1 dating? You can say 5. Okay, that's good. That's cute. And who's 2 dating? 5. Okay, that's cute. We're good. And who's 3 dating? 5. That's cute. That's good. And some of you are like, Mr. Tyson, you've lost your mind. This is not a function. This can't no way this is working. But it meets our definition. Our definition says for each x value must connect, or each x value must connect to only one y value. It does not say that the y has to have one x. It says the x has to have one y. It's an alphabetical order. The x goes to a y, and that's the definition. This does meet the definition, because it couldn't be more than one arrow leaving an x. As hurtful and horrible as that is, this is a function. For space purposes, I'm going to put an F there, but it is a function. And the reasoning, because it says to explain your thinking, is that for every x, there's one y.